Hello, how y'all doing today? My name is Bernie Thompson, and today we're here to take a look at this 2000 Chevy Tahoe. This little Tahoe's check engine lamp is on and it needs to be turned out so this vehicle can pass an emission test. Now, unlike most cars that I work on that have been worked on by every technician west of the Mississippi, no one has worked on this car. This is my sister's car, and she needs the check engine lamp to be turned out so she can pass an emission test. She doesn't have a lot of money, so she asked me to take a look at this vehicle and to get it fixed for her. So the first thing I want to do is get a scan tool and get some basic data. So let's get that scan tool on here and get some basic data. Okay guys, we got our scan tool up. Let's go get the DTCs. Okay, so I got a P0121, a P0122. So I've got TPS codes. So I want to go get the PIDs. I want to clear all the PIDs, and I want to just get the just the TPS sensor. Now we want to go over to graphs. I want to go to combo graph. The yellow line is the TPS. I'm working the accelerator pedal now, I'm pushing it. And we have no movement. The TPS is absolutely staying at zero. It's not seeing any TPS movement at all. Okay guys, I need to go get a scope, and we need to get a scope on this TPS. So let's go ahead and get that scope on this TPS. Okay guys, I found a wiring diagram. Here's the throttle position sensor. It's a basic 3-wire sensor. Black is the ground, gray is the 5-volt reference, this is the current path to make it work, and dark blue is the sensor. So on the dark blue, the sensor, I put channel 1 yellow. On the 5-volt reference, I put channel 2 red, and on the black, I put channel 3 in green. So I have yellow, red, and green on these wires to connect to this sensor. Let's make sure that we're connected right. We'll come over here. We're in the wires because the check lamp is off. This is a circuit that I designed many years ago that allows you to know if you've back probed the circuit correctly. If the red light's on, you're not in the circuit. This is a really cool feature, guys. So I'm in all the circuits, we know that now. I have 5 volts and I have a ground, so I have a current path established. Now, I'm going to open the sensor up. So I'm opening the throttle position up. Who's pulling it down? If this 5 volts, if I have no signal out and I've got 5 volts in a ground, I should have a signal out. If I don't have a signal out, I never ever associate that with the sensor that's bad. I associate that with someone's pulling it down. So who could pull it down? The sensor could be bad, the wire could be shorted, the micro could be pulled down, it could have some kind of a trace that's sitting in water. There's many things I've seen that will pull this down, but the only way to know what's wrong is I need to do another test. It's a really simple, basic test. It's really quick. Let me show you guys what we're going to do. So I want to go to outputs, and I want to put 5 volts out of my scope. Let me show you. So what I've done here is I've come to my TTL out here, and I got this wire right here, and this scope will feed power out this wire, or it will feed voltage pulses out, frequency out. But right now I've just got 5 volts. So let's go back over here. Now if I'm feeding voltage out, it's going to come up on the blue wire because I'm putting it to 5 volts. Okay, so I'm putting 5 volts. I know the scope's putting 5 volts out. Now I'm going to connect it to this yellow output, and I should see 5 volts. If I don't see 5 volts, it's being pulled down. It's that simple, guys. This is a really, really simple test. Okay, so I connected it. I only have 1 volt. I don't have 5 volts. So this circuit is being loaded. It's being pulled down, guys. I know that right now. Now, what I don't know right now is who's pulling it down. Is the PCM pulling it down? Is the wire shorted, or is the sensor bad? Now, this is really easy to figure this out. All I got to do is unplug the TPS. So let's do that. Okay, so we're going to disconnect that connector. Okay guys, before I unplug the TPS, I want to change the scale so it's easier to see when something changes. So we're going to change this from 50 volts to 5 volts, because 5 volts is what we're dealing with here. So now we've got 5 volts. We can see I have 5 volts and I have my ground. This is my current loop that's producing this output. Now the 1 volt, remember, is being caused because I'm putting 5 volts out from my scope, and I've got it connected into the signal wire. So if I unplug the TPS and this comes up to 5 volts, the TPS is bad. If I unplug the TPS and it doesn't come up, it stays loaded, then I've got to unplug the correct connector from the ECM. If then it comes up, then the ECM's bad. If it's still pulled down, then it's in the wiring or the connector. So this is a way to isolate who's pulling the circuit down, okay? So now we want to unplug that sensor and see what happens. Where's the problem in this circuit? There's a really quick, easy way to find this problem. Okay, I've got it disconnected, and we've got 5 volts that came up. So the problem is in the TPS. Something's happened to the TPS sensor. Very unusual problem to have the TPS load the circuit. This is really cool, because this is really different. I thought that this problem was going to probably be in the wiring, but apparently it is the sensor, because I unplugged it, we've got 5 volts. So that clearly indicates where the problem is located. The TPS is the problem. TPS is loading it. Okay. So now we know what we got to do to fix this vehicle. Okay guys, I went over and I got a throttle position sensor. I went to GM. I wanted a factory sensor, but I guess they've discontinued this sensor, so I had to get an aftermarket sensor. But now we have about 0.5 volt on the sensor, which is what I expect at idle. So let's go ahead and let's go to multi-tool. Now this is going to be my TPS right here from the scan tool. So now let's operate the TPS. And we can see that I'm moving my voltage and the micro is seeing this. Okay guys, so this vehicle is fixed. This is ready to give back to my sister. Okay guys, is that just a cool trick or what? I've been using this technique for many, many years, and it has saved me so many headaches. It's so easy, so quick, so accurate. This is a great operational tip to find any circuit that's loaded. Anytime that I'm looking at any kind of sensor output voltage and it's really low, I always think that it's pulled down. And this is a really good way to prove who's pulling it down. But there's one thing that you all got to understand right now that's super, super important. Okay, the TPS wasn't working on this vehicle. Okay, what is the TPS? That's your interface between the driver and the ECM, the micro. All computers have to have some kind of an interface. On your PC, you're using your mouse. You move your mouse around. That's asking the micro to do a task for you. The TPS is the interactive, or that's the mouse that's giving the microprocessor what? Driver intent. Am I idling? Am I wide open? Now, when the micro doesn't have that data, it's going to suspend the tests, because that's a really important piece of data that the micro has to have in order to properly run the DTCs. The DTC is the test. So to run these tests, a lot of these tests are going to be run with the TPS. It needs to know if it's idling or if it's under light load or it's under wide open. It gets that information, and a lot of times from the TPS. Also, tranny shifts go by TPS many times. So if the TPS doesn't work, the one thing I'm certain of is we've suspended testing on many of the functions. So you need to educate your customers before you give them the car that the light might come back on, because now that the TPS is in operation, it's going to start running all these tests that have been down for as long as that part's been bad. And I know my sister, she waited, this light's probably been on for a year, and she waited until she had to get it fixed. She has to go in to get an emission test. So chances are this car is going to be back to me for another problem once the testing starts to run. She's got to run it a few days anyway just to run through the monitors. But I can really believe that this car, just because I know how my sister is, that this car is going to be back, and I'm going to need to work on other things because the testing will start. Now, what this is so important for you guys is you got to relay this to your customers. When I had my shop, every time we fixed problems, I educated my customers that the check engine light might come on because now the car is going to start running tests again from the suspension being lifted, and it's going to start to go through and run these tests, and it might find other problems. And if the check engine light comes on, let me know and we'll take a look at it. And you know what, guys? You know what that bought me? I no longer got these calls that I just had my car fixed in the same problem. I've got the check engine light on. No, they'd call me and say, you know, I think it ran some more tests and I have another problem. What a difference, guys. Educate your customers. You got to do this stuff. Now, let's see what happens. Wow, that sounds so much better. My sister's going to freak that her car actually runs again. Incredible, huh? Some people, I tell you. But the bottom line, guys, is educate your customers. Make sure that they know when this car goes back to them that the car is going to start to run tests again, and it might find another problem. It'll save you guys lots and lots of headaches. And guys, this is a great simple test. I've been using it for over 20 years, and it has saved me a lot of headaches and time. This test, this technique just works. Hey guys, use scopes in your shop and you'll have good success too.